For the first time in the history of humanity, a human hand will attempt to deflect an asteroid from its trajectory to allow future generations to protect themselves from mortal danger. Because among these millions of small celestial bodies which occupy the solar system, some threaten to one day crash into our planet and destroy all forms of life here. Planetologists, astrophysicists, geochemists, scientists from around the world today form a network of thousands of sentinels who track, observe, and study right to the heart of these space stones. Because if some of them represent a threat to humanity, each of these asteroids carries within itself the best-kept secrets in the history of the solar system, the key to understanding the appearance of life. For scientists around the world, the hunt for asteroids located millions of kilometers from us begins here, on Earth, in the most remote places on our planet. Nick Moskowitz is an astronomer at the Lowell Observatory in Arizona. And he's one of the asteroid hunters who observes these tiny space pebbles from Earth. But the place he chose is unique in the world. It's a place that bears a giant geological scar, the mark of an asteroid that crashed into Earth several thousands of years ago.
We are here at Meteor Crater, where something like a 50-meter asteroid came in through the atmosphere and impacted about 50 or 60,000 years ago and made this spectacular impact crater that's still preserved today. Impactors from space are coming in at 30,000 miles per hour. So a 50-meter body comes in and makes a kilometer hole in the ground. When a piece of space debris is out in outer space before it hits the atmosphere, before it hits the Earth, we often refer to it as a meteoroid. As that meteoroid is coming in through the atmosphere and burning up, we call that a meteor. And if that rock out in space is big enough to survive all the way through the atmosphere and land on the ground, we refer to that as a meteorite. And all of these things, meteorites, meteors, and meteoroids, come from asteroids out in the solar system.
By hitting the ground in Arizona, the heat and blast generated by the collision probably instantly destroyed all life within a radius of 4 kilometers. And up to 22 kilometers surrounding, a shockwave moving at a speed of 2,000 kilometers per hour swept away everything in its path. But the meteorite that crashed here is nothing compared to another asteroid whose fall had consequences on the scale of the entire planet.
One of the largest and perhaps most famous ones on the planet is an impact feature called Chicxulub, which is off the southern coast of Mexico. 10 or even 20 kilometer body that came in and created a massive crater about 65 million years ago, and we think that impact may have led to the extinction of the dinosaurs.
When it crashed, it deployed energy equivalent to several billion times an atomic bomb. This planetary catastrophe caused a mass extinction, 75% of life on Earth. Astronomers are therefore sentinels on the scale of the entire planet and scan the sky using different technologies. To observe the asteroids in the sky of this privileged area at night, Nick installs a system of multiple cameras whose images are then assembled into one to increase their precision.
So when meteoroids come in from outer space, they lose something like 90% of their mass, and that's why they glow as they're coming in through the atmosphere, as they're losing material and it's getting vaporized. Any given night, if you were to somehow lay on your back and watch the entire sky for 12 hours straight, you may see 300, 400, 500 meteors from one location. And that's true for wherever you are in the world. And the benefit of having the cameras on sky is that they can keep their eyes open all the time. They don't get tired. They can stay awake all night and watch the entire sky. And so that's why we're able to detect so many meteors within a single night.
Observing these hundreds of shooting stars burning up in the sky allows scientists to calculate their trajectory and origin.
For the objects that are big enough to survive that intense heating and passage through the atmosphere to land on the ground as meteorites, well, that's even more valuable because we have fresh pieces of space rock.
In the four corners of the planet, specialists have already discovered thousands of these stones from space. And hundreds of collections bring together these precious fragments, witnesses to the diversity of shapes and textures of the rocks populating our solar system. One of the most important private collections is kept at the National Superior School of Geology in Nancy. It belongs to Giovanni Zingo, who has been passionate about these extraterrestrial rocks since his early childhood.
I started minerals at the age of 9. At 20, 22, I started studying meteorites. It's a lifetime. If you count all the meteorites I've collected, I don't know, at least 5,000, 6,000.
Amongst all those precious specimens which come from all horizons, Giovanni is lucky enough to have a fragment of meteorite known for being the first one witnessed by a human in 1492. A child from the village called Ensisheim in Alsace saw this meteorite crash in a field and immediately warned the community about it.
It was a matter of pride for people there. To give you an idea, it was kept in a church. People prayed next to the meteorite because it was sent from the sky.
To build this spectacular collection, Giovanni learned to sharpen his eye to spot meteorites in the most varied environments.
I was a great diver. I found 2 in the sea. You don't have to go hunting. You can come across a meteorite just like that, out of the blue. Farmers, for example, when they work their land, everything that is rocky, they put to one side. And there you find on this pile meteorites.
Since their surface was altered by their passage through the atmosphere, we have to go to the heart of the meteorites to discover their true nature. Once cut, these new fragments are shared with scientists who analyze them to unlock their secrets. Because what was once considered simple space gravel is today a prominent object in the eyes of researchers.
For a long time, we neglected asteroids, and we realized lately that they contained essential elements on the history of the solar system.
Patrick Michel is an astrophysicist at the Nice Observatory. A specialist in asteroids, he's convinced that these small celestial bodies are one of the keys to understanding the formation of the solar system. Today, Patrick entrusts a special mission to Guy Bourrel, whose speciality is cosmochemistry. That is to say, the study of the chemical nature of celestial bodies. His challenge is to analyze the tiny fragment of a meteorite that may come from a primitive asteroid in the solar system. The team members decided to carefully examine this fragment using a scanning electron microscope. It enables them to analyze mineral elements 100,000 times smaller than a millimeter.
And if we go on this side here, what do we see?
Well, there it's really interesting because we see a chondrule. And there what you can see on this picture are olivines, which really constitute all the matrix.
And so, in fact, is that one of the most ancient materials of the solar system?
Exactly. It's the first 5 million years of our solar system's formation.
Under the eye of the different microscopes used by scientists, meteorites reveal an unsuspected beauty. Through the numerous filters used, the multiple minerals making up these pebbles from space create an infinite mosaic of colors, each nuance of which is a treasure trove of information to reconstruct the history of the solar system.
Meteorites are gold mines in terms of information because they contain some of the elements that allow us to go back in time. And in particular, we have been able to date the age of the solar system, the origin, at 4.567 billions of years. It's easy to remember 4, 5, 6, 7 by analyzing the composition of certain inclusions which are in certain meteorites and by dating them. And these elements represent the oldest ones at our disposal. For us, they date the zero moment of the solar system.
Just after its appearance, the young sun is surrounded by a disk of gas and dust. These microscopic dusts come together little by little until they give rise to massive bodies several hundred meters in diameter. Scientists call these primitive bodies planetesimals. All over the solar system, these planetesimals are colliding with each other. After millions of years of uninterrupted collisions, they eventually aggregate and form several immense bodies which will become our planets. One of them is the Earth, which for the moment, like the other planets in formation, has neither water nor life. But in this violent accretion process, certain planetesimals escape the force of gravity of the young planets and break up into thousands of asteroids, which continue their journey through the solar system. Some of them traveled through time to our era on our planet's trajectory.
From a far corner of space, this is a huge fragment of the meteorite that exploded over Russia in February. It's believed to be the largest piece of space rock to hit the Earth when a meteor broke up over the towns of Chelyabinsk, Yekaterinburg, and Tyumen. The force of the shockwave when it hit Earth was estimated to be as strong as 20 Hiroshima atomic bombs.
In February of 2013, a 20-meter asteroid came in and hit the Earth's atmosphere and impacted around 9:30 in the morning over the city of Chelyabinsk, Russia. The asteroid that produced the Chelyabinsk impact came at us from the sunward direction, so we did not see Chelyabinsk coming. The asteroid actually exploded in the atmosphere, and the shock wave from that explosion came down to the surface and shattered windows and broke down walls and collapsed roofs in some cases and did a fair bit of damage to the buildings in the area around Chelyabinsk. And a lot of people actually got injured from this event.
This tragedy reminds all humanity that asteroids represent a deadly threat that can strike anywhere and at any time. This is why the international community has decided to weave a sky surveillance network called planetary defense. On 5 continents, thousands of scientists become sentinels, whose mission is to monitor the sky to identify asteroids that risk colliding with Earth.
Asteroid impacts aren't a problem for the planet, they're a problem for the people on the planet.
To monitor these small celestial bodies located millions of kilometers from our planet, scientists begin by setting a first objective. Locate them from Earth to follow their movement and calculate their trajectory. The Catalina Sky Survey Observatory is one of the most efficient in the world. It has 3 telescopes which scan the sky 24 hours a day to draw the celestial map of asteroids. Eric Christensen is an astronomer and leads the observatory team whose mission is to locate these small celestial bodies.
Arizona is a great place for observatories because of the high fraction of clear nights. We have relatively low light pollution. This telescope is one of the most prolific and productive discovery telescopes. To cover the entire sky with this telescope, it takes about a month. And once we've covered the entire sky, we have to cover the entire sky again, and again, and again. And we do that month after month, year after year. Hey, Josh, how's it going?
Just peachy.
Good. Ready for another night of asteroid hunting?
Always.
So where are we looking tonight?
We're looking right here tonight.
All the way to the Milky Way, okay?
Yep.
Right now, our focus is on finding asteroids that are down to about 140 meters in size, which if an object like that were to impact, it would cause significant regional devastation. If an object like that were to impact in France, for example, France would be devastated. That's one of the things that motivates me to keep searching the skies night after night.
The celestial mapping of asteroids is surprising. It reveals that most small celestial bodies in the solar system do not move in a chaotic way and are precisely located in 2 areas far apart. The furthest from the Sun, called the Kuiper Belt, is located beyond Neptune, at the edge of the solar system. The closest, which is also the densest, is located between Mars and Jupiter. But under the influence of Jupiter's immense gravitational force, some of these asteroids are ejected from the main belt. These asteroids, whose trajectory risks crossing that of the Earth, are called near-Earth objects.
So with this telescope, we have discovered hundreds of thousands of asteroids. We're only focused on the near-Earth asteroids, and in a given year, with this telescope, we find about 1,000 near-Earth asteroids.
The first coordinates of the identified near-Earth objects are transmitted to the network of planetary defense observatories. That of Roque de los Muchachos, located on the island of La Palma in the Canary Islands archipelago, is one of these guardians who track the most dangerous asteroids.
Here in the Canary Islands, we have 2 observatories, and we do plenty of follow-up observations of all these potentially hazardous asteroids that can be impacting in the future with the Earth.
This mission is crucial because our Earth has recently faced a real risk of disaster.
Years ago, we discovered this very, very interesting Apophis asteroid. And at the beginning, with a few observations, the probabilities of impacting the Earth in the future were not low. They were actually pretty high. We actually were really scared when we discovered Apophis because it's quite big. There were several coordinated campaigns to actually determine its orbit as precisely as possible because the probabilities of impacting were really high. That's why we put so much effort into observing it and using all the telescopes available in the whole world.
The giant asteroid measures 325 meters in diameter, more than twice the size considered dangerous in the event of impact with Earth. Its mass is estimated at 50 million tons, which would cause a crash with a power equivalent to 52,000 times the Hiroshima bomb. This asteroid is named Apophis, after the personification of chaos in ancient Egyptian mythology. Scientists' first calculations indicate that Apophis will collide with our planet on April the 13th, 2029. As soon as this discovery was made, scientists of the planetary and defense all around the world coordinated to monitor this potentially deadly asteroid. For several months, they scrutinized its every movement to clarify day after day the calculation of its trajectory.
And thanks God, it ended up not impacting the Earth as we added more and more observations. This is a perfect example of how important are these observations for the planetary defense.
After several months of observation, scientists refined their calculations and now estimate that this asteroid will not collide with the Earth. It will only brush against it. Its journey will take it 31,000 kilometers from our planet, closer than certain satellites placed by humans in Earth's orbit and much closer than the Moon. But Apophis remains a threat that must be monitored closely.
This object is still interesting because we have to keep an eye on it. Every time it approaches the Earth, its orbit is slightly modified so it can be impacting the Earth in the future.
Night after night, the Planetary Defense Network activates to identify and track as many near-Earth objects as possible. But for scientists, this monitoring will not be enough. We must go much further in the face of the threat of an asteroid impact with the Earth.
The asteroid impact threat is actually a threat that we can avoid. It's unlike an earthquake, where if an earthquake happens, we cannot stop it, or a tsunami or something like that. But an asteroid impact, if we have sufficient warning, we see there's an asteroid coming, we can make it miss the Earth.
Nine, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of the Falcon 9 and DART on NASA's first planetary defense test to intentionally crash into an asteroid.
November 23rd, 2021 was a historic day for planetary defense. NASA launched the DART probe into space. This was the first part of the AIDA mission, an international adventure that scientists had been preparing for more than 20 years.
The AIDA mission consists of both the DART and the Hera missions, and it's a planetary defense tandem. The DART mission is going to impact the asteroid Didymos at 6 kilometers per second. It is going to try to deviate the asteroid in space, so change its trajectory. Then we have Hera. Hera is going to come with the eyes of the mission. It's going to observe what has happened, look in detail, and we need that information so desperately in order to validate the numerical simulations we have so that in the future we can reliably use those simulations if we find an asteroid that is threatening.
55 minutes after takeoff, the rocket released the DART probe more than 7,000 kilometers from Earth, and the spacecraft began its great odyssey of no return.
DART is the first mission for planetary defense, and of course, as that, we had one spacecraft with one telescope. So the spacecraft itself is human-sized, about 2 by 2 by 2 meters. It has very long solar arrays that roll out that are about 27 meters when they're fully extended. And we demonstrated a lot of technology for NASA as part of this mission, including these new types of solar array, an ion engine, Draco, and so-called SmartNav, which is a set of algorithms that allowed us to actually hit the asteroid.
DART's journey lasted a year. In the crosshairs of this projectile probe was Didymos, a tiny asteroid 160 meters in diameter, located 11 million kilometers from our planet. It orbited Didymos, a body 800 meters in diameter. This first deviation test was preceded by numerous asteroid exploration missions. For more than 20 years, scientists have sent probes millions of kilometers from Earth to observe these mysterious bodies and understand them better.
But in reality, what interests us is to understand what their surface properties are. Is it hard rock? Is it sand? Is it gravel? What are their internal properties? Understand their shapes. And for that, we must send space probes and explore them directly.
For nearly 25 years, several asteroids have been photographed from all angles by space probes that set out to meet them. Mission after mission, technological progress makes it possible to produce increasingly precise images, gradually revealing the nature of these bodies, which are very difficult to observe from Earth. In 2014, Japanese scientists carried out an exceptional mission, the Hayabusa 2 mission. The aim of the mission was Ryugu, an asteroid with a diameter of 875 meters, 300 million kilometers from Earth. After a long journey of 4 years in space, this probe managed to take samples from an asteroid and bring them back to Earth. This was a world first and unique access to a true scientific treasure. Once these precious fragments are brought back to our planet, they must be kept protected from the terrestrial environment, because this environment could contaminate the space rock and risk altering the analyses. So the scientists brought the samples here to this sterile, high-tech laboratory at JAXA, the Japanese Space Agency. Seiji Sujita was leading a team of young researchers who had the privilege of studying samples from Ryugu. They analyzed and classified each grain of dust taken from the asteroid. Their task was colossal. It would take several years.
The amount of samples we gathered from the surface of asteroid Ryugu is 5.3 grams. This is 53 times more than our minimum success criteria, which is 0.1 gram. Very tiny. That was still large amount enough that geochemists can really answer most of the fundamental questions we wanted to answer.
The electron scanning infrared microscope made it possible to analyze samples at a molecular level, on a scale of up to a few tens of microns. Patiently and methodically, the team identified and classified each grain of this extraterrestrial dust, then made them available to researchers around the world. But what did this analysis reveal? At Tohoku University, Professor Tomoki Nakamura is a specialist in planetology. He's one of the scientists in charge of in-depth analyses of samples from Ryugu.
Ryugu sample, it is rock, but very reactive. If we expose Ryugu sample to atmosphere, it change like a creature because oxygen attack. Then the oxidized mineral become another minerals. Therefore, we have to keep a Ryugu sample inside of the glow box. The Ryugu sample is a kind of a mixture of different small particles. We found a liquid water completely encapsulated in crystal. That means Ryugu originally contain abundant water. And in addition to that, we detected carbon dioxide, and this is important, and organics.
Those chemical elements are essential to the creation of life. Analyzing an asteroid fragment on a microscopic scale reveals another fundamental secret of the universe. This new discovery lifts the veil on the most important moment in our history, the appearance of life on Earth. Because several billion years ago, at the time of the formation of the solar system, the instability of gravitational forces caused a massive rain of billions of tons of asteroids on Earth. This cataclysmic event changed its destiny forever.
Asteroid may have brought a lot of water and organics, those are building blocks of life. And also, it may have brought a lot of energy to promote the chemical reaction that may lead to a formation of life and the biomolecules in a time of 4 billion years ago or even earlier. So either way, asteroid may have played a very important role.
At the precise moment of this asteroid shower, the temperature of the young planet Earth was neither too high nor too low. It was located in what astrophysicists call the habitable zone of the solar system. This exceptional situation allowed chemical elements brought to Earth by asteroids to give birth to life there.
I sometimes get the question about, didn't the same thing happen to the other planet? Answer is yes, it must have happened when the Earth received a lot of impacts of asteroids and possibly comets. Other planetary bodies like Mars and Venus must have received a similar magnitude of impact. And in fact, Mars may have life or may have had life in the past, possibly in the present time.
Thanks to the information collected by the various asteroid exploration missions, scientists are discovering the geological nature of these space rocks. And this understanding is decisive for future missions.
In the Hayabusa 2 mission, there was an incredible operation, which was to make an impact on the asteroid Ryugu. And we realized that, even if we thought that the surface was hard, when we hit the asteroid, it almost reacted like a fluid, like a sort of sand without any cohesion. This is very important data for the planetary defense, because one of the techniques we want to use to protect ourselves from an asteroid impact is to send a projectile to hit it and deviate its trajectory.
How can we evaluate from Earth the speed of impact and the quantity of energy necessary for the deflection of an asteroid? At the Japanese Space Agency, a giant cannon with exceptional properties is used to carry out tests to simulate on Earth the course of the impact that will take place in space.
The collision cannon is a tool used to fire projectiles at 5 kilometers per second. This is exactly the collision speed of celestial bodies in an asteroid belt. In Japan, there are few cannons capable of delivering projectiles at such speed. It's also rare on a global level.
This gun is equipped with numerous sensors and several cameras capable of recording the passage and impact of projectiles at several thousand images per second. The target of this experiment is a 6-centimeter diameter ball made up of tiny glass beads agglomerated to simulate the presumed structure of the asteroid.
The cannon is charged.
Okay, I'm arming the shutter. 3, 2, 1.
Patrick Michel and Akiko Nakamura then come to examine the recorded images and analyze the results of the experiment. Their objective is to verify the accuracy of the numerical simulations carried out by Patrick for the DART mission.
Wow, yes, so that was a catastrophic disruption.
Yes.
Immediately we see the cracks forming here also and the antipode.
Although the target was 40% porosity, but it's still efficient to transmit the energy.
Yeah, and if we do that, then for that, it will work.
Yeah.
Okay.
Yeah.
Good.
Really good.
With this miniature test of a collision between a tiny object and an asteroid, scientists can now adjust the trajectory and speed of the DART probe so that it crashes into Dimorphos at the best possible angle. But a few months before this impact, this trajectory must be constantly monitored to ensure the success of the mission.
DART is going to hit the asteroid. We have to hit the asteroid. Otherwise, it's a complete failure.
This moment-to-moment monitoring takes place here in Washington at NASA's Applied Physics Laboratory. Andy Cheng is one of the scientists responsible for this mission, as is Elena Adams, who leads the operation. Because despite all their preparatory calculations, unexpected events can compromise the mission at any time.
We always knew that DART was going to be hard. When we started taking data of the Didymos system for the first time in April of 2022, we started seeing that if we feed that data into our SmartNav system, the probability of impact was actually going to be much lower than we expected. In July, it was at about 50%, which 50% is a towing cost, whether you're going to hit it or not. What it was seeing, apparently, was heaters turning on and off. And the system is sensitive enough that it was moving the field of view by just 20 microns. A human hair is 20 microns, and that was sensitive enough to have a probability of miss of about 50%. Now, we fixed it. And we were very lucky because we were able to find the issue, we were able to fix it, and at this time, the probability is actually 99% that we will impact the asteroid. But there's always that chance that the system might not be what we expect, but.
I am, on the one hand, confident that we will hit the asteroid, that we've done all the preparation, we've tested everything very carefully, very thoroughly, every way we can think of. And at the same time, I'm very tense, a little bit anxious also, because it's actually very hard. It's something we've never done before, no one's done before, and it's a very complicated system. Then yes, it's something to look forward to, that to be a part of the first mission that practices or shows that it may be possible to save the Earth someday from an asteroid impact.
September 26th, 2022, D-Day. A little over a year after its launch, the journey of the DART probe was coming to an end. After 20 years of hard work to set up this exceptional mission, the planetary defense community would finally know if the American probe would hit its objective, located 11 million kilometers from Earth.
Since November 24th of 2021, we've been targeting Didymos. And then at 1 hour out, once Dimorphos emerges from behind Didymos and we're able to detect it, and by we, I mean the spacecraft, because it has to do everything autonomously, then it will be able to change from Didymos to Dimorphos and start guiding itself into it.
To witness the success or failure of this historic mission, all the DART mission scientists gathered in Washington. Here at NASA, researchers and media from around the world had their eyes glued to the images sent back to Earth by the probe.
Today is the big day. Today is the impact day of the DART mission. This is the first test that NASA is doing to test an asteroid deflection using a kinetic impact. So please be a part of this historic cosmic event, and it's a once in a lifetime.
Oh my God. It's unbelievable. We can see rocks on Dimorphos. That's incredible.
NASA experts were hanging on to the latest images emitted by DART and controlling all the parameters of the mission while there was still time.
There is about 38 seconds of delay, one-way light time, plus additional time on all of these computers to process all the data coming in and get it to your screens, and then for the humans to decide of what to do. So all of this takes time, and that is why the spacecraft has to be autonomous.
We are now exactly 2 minutes and 58 seconds to impact. And what you're seeing right now on your screen is all live images from a camera that is mounted on the DART spacecraft.
That's pretty long.
A few seconds before impact, the tension was at its maximum. The scientists helplessly watched the final moments of their spaceship. At the edge of the solar system, it had undoubtedly already crashed into its target. The impact of DART on Dimorphos was a scientific event of global magnitude.
Andy, this is amazing.
I know.
I don't know how I feel. I cried, I jumped for joy. I told myself, that's incredible, we did it.
The actual experiment has just started because we hit the asteroid. We now have to study the effects, what happened. And some of the first results have already come in, and so they do see the dramatic brightening of the body and the formation of the ejecta cloud. So we're going to have to continue tracking that over the next few weeks, probably, and we have to see what's in those pictures.
The first observations allowed scientists to see the unqualified success of the mission. The asteroid had indeed been deviated from its original trajectory, which was now changed forever. For the first time in history, the hand of humans had succeeded in deflecting a space object. And the collision had an unexpected consequence: the appearance of what looked like a comet tail that Dimorphos was now trailing. This strange phenomenon was already intriguing specialists, all of whom were eager to now launch Hera, DART's sister mission.
All of this is essential now. We can't do anything without it. It's like the icing on the cake. We'll be able to do that, and it's thanks to international cooperation at its best level. NASA is making the impact, Europe will arrive to do the exploration, and the scientists are excited and working hard for it. It's great.
After the success of DART, its European twin mission Hera will take over to observe the asteroid hit by DART from every angle and examine the consequences of this collision. But the technological challenge of this mission will be quite different and an even more difficult feat to achieve.
When you want to fly very close to the surface, you cannot control the spacecraft from ground anymore. You need onboard systems to be able to derive autonomously the maneuvers that are needed to place the cameras exactly where you want them to be.
The first navigation tests are being carried out here, in Madrid, in a robotics laboratory. Space control engineer Andrea Pellicani is developing artificial intelligence software that will allow the probe to reach the asteroid Didymos. To do this, it recreates in miniature the situation the probe will encounter at the edge of space.
One of the facilities that we are using to validate our subsystem is the platform art. We will have two robotic arms, one holding the camera and the other one holding the two asteroids.
Thank you, thank you.
Welcome at GMV.
Thanks.
Ian Carnelli, one of the leaders of the Hera mission, has come to discover the device used to simulate the navigation of the European probe.
Nice. So we see some results?
I think so. We have also the different mock-ups, the big one of the Morpho of Didymos, the smaller one of the Morphos, so to test different scaling scenarios. So yeah, today is going to be
nice.
It's going to be fun.
How's the team doing?
Well, stressed, but it's Hera.
Deep space navigation is like old sailors. So we're going to track some stars and navigate the spacecraft against these stars. We also have star trackers that have star maps and confronting that tell us the attitude of the satellite. But the final targeting to the last maneuvers will really be calibrated by looking at fixed stars that we select within the field of view, and then track the movement of a point of light, which is Didymos, within these stars to arrive to our target.
Platform art is very useful because we can actually emulate the dynamic condition that we have in space. Dynamic conditions, illumination conditions, all of these will be simulated through the relative motion between these bodies.
The movement of the miniature replicas simulates the real trajectories of the two asteroids. The data collected teaches the artificial intelligence to anticipate all possible scenarios for approaching the probe. At the end of its 2.5 years of travel, the Hera probe will be approaching the asteroid Didymos. But 196 million kilometers from Earth, it'll no longer be able to be controlled from the ground. At this precise moment, artificial intelligence will fully control Hera so that it can fulfill its mission.
This is a totally new technology. It is the first time that ESA flies it in the space, and even worldwide would be a first. The system will take images from its cameras and derive on board its position and velocity with respect to the surface by following the motion of rocks, boulders, and craters. And that's when we start our instrument phase and getting all the scientific data. We'll get beautiful images, but we'll also get colors to understand the composition of the asteroid. We'll get internal structure through a radar. We'll deploy CubeSats like drones close to the surface. It's going to be an amazing mission. We'll get 3 cameras at the same time looking at these objects from various angles and get all the data that we need to validate our computer models and reconstruct the DART impact on ground so that we know exactly what has happened and be able to validate this technique for other asteroids.
The Hera probe will closely examine the consequences of the DART impact on the asteroid Didymos. and many other current or future missions study asteroids. On October 20th, 2020, the probe OSIRIS-REx collected samples of the Bennu asteroid. It brought them back to Earth in September 2023, thanks to a capsule preciously retrieved by scientists, who hoped that those samples would reveal other unsuspected secrets about our solar system. For Patrick Michel and all the others, the study of these small, distant, and undisciplined bodies is only just beginning.